At 4:17 in the morning, the mountain moved, not metaphorically. Men standing half a mile away felt the vibration rise through their boots before they heard the machine itself. Then came the sound. A deep, metallic roar rolled across the valley with the force of artillery fire. The shovel's bucket descended slowly at first. 90 tons of forged steel teeth struck the mountainside hard enough to fracture bedrock in a single blow. Inside the operator's cabin, 3 men worked in temperatures that swung from freezing winds to suffocating boiler heat. It hauled the iron that forged bridges, warships, skyscrapers, railroads, artillery shells, and entire American cities. Railroads crossed deserts, forests, and frozen mountain passes with mathematical aggression. The Mesabi Iron Range in Minnesota became the center of this transformation. Discovered in the 1890s, the region contained enormous low-grade iron deposits buried beneath layers of earth and rock. In boardrooms lined with dark oak and cigar smoke, mining executives confronted a problem that threatened the entire industrial economy. Construction became an industrial project of its own. Thousands of workers participated in manufacturing the giant's components. Steel foundries operated continuously to cast reinforced gears weighing dozens of tons each. Railroads transported machinery parts across several states using specially modified freight platforms. Riveting crews assembled major sections at temporary fabrication yards near the mining site itself, because transporting the completed structure intact proved impossible. Even assembly carried deadly risks. In one incident during construction, a suspended drive gear slipped from its crane supports and crushed 2 riggers instantly beneath 27 tons of steel. Weeks later, a boiler installation crew suffered severe burns after a pressure valve ruptured during testing. Newspapers rarely mentioned such accidents beyond brief industrial notices. Human loss was already accepted as part of heavy engineering expansion. When the machine finally stood completed against the horizon, witnesses struggled to describe its scale accurately. Its steel frame towered above nearby buildings. Smokestacks released constant columns of black exhaust visible for miles across the range. Workers climbing the outer structure used ladders and maintenance walkways resembling those found aboard naval warships. At night, floodlights mounted across the superstructure illuminated the excavation pit like a military encampment. The first operational test drew executives, engineers, journalists, and railroad officials from across the region. As steam pressure climbed, the entire machine vibrated with restrained force. Pistons hammered inside their cylinders. Drive gears rotated slowly at first, releasing deep metallic echoes across the quarry walls. Then the boom lowered. The bucket struck the earth with enough force to shake nearby observation platforms. Tons of rock tore free instantly. A roar rose from the spectators. Some saw industrial salvation. Others saw something closer to mechanized conquest. But everyone understood the same truth the moment the giant completed its first excavation cycle. American industry had crossed into a new age of extraction, and there would be no returning from it. From a distance, the giant appeared almost motionless. Its movements were too large, too deliberate, for the human eye to immediately comprehend. The boom descended with the slowness of a collapsing bridge. The bucket rotated through, the air like a steel planet suspended, from cables thicker than railway rails. Smoke drifted continuously from its boiler stacks while the surrounding earth vibrated beneath every excavation cycle. Only from inside the machine did its true violence become visible. The interior was not a single chamber, but a network of mechanical compartments layered vertically through the superstructure. Boiler rooms occupied the lower sections where coal crews worked beside roaring furnaces that operated day and night. Above them sat the drive assemblies, Enormous gear trains transferring steam power into rotational force strong enough to move thousands of tons of machinery against gravity and resistance from fractured rock. Nothing inside the giant was quiet. Steam hissed constantly through high-pressure pipes wrapped in insulation blackened by grease and soot. Pistons slammed forward with rhythmic concussions that shook maintenance platforms beneath workers' boots. Gear teeth several feet high collided with enough force to produce sparks during overload cycles. Communication between crew members often depended on hand signals because ordinary speech vanished beneath the mechanical thunder. At the center of operations stood the control cabin. The operator's compartment resembled the bridge of an armored ship more than a mining vehicle. Pressure gauges lined the walls beside brake levers, hoist controls, clutch systems, and cable regulators. Windows thick with dust and vibration offered limited visibility across the excavation pit below. Operators relied heavily on instinct and crew coordination, because depth perception became unreliable when controlling machinery of such immense scale. A single excavation sequence required exact timing. First came positioning. The traction crew adjusted the machine's orientation using massive crawler assemblies driven by steam-powered reduction gears. Even minor directional changes demanded enormous force, because the structure itself weighed 12,000 tons before loading additional material. Then the boom operator lowered the bucket. Steel cables unwound through giant pulleys mounted high above the main frame. Each cable carried enough tension to kill instantly if it snapped under strain. Engineers calculated stress loads constantly because overloaded lines could whip through machinery with catastrophic force. Several operators described the sound of failing cable strands as similar to rifle fire echoing through metal corridors. Once the bucket struck the earth, the hoist engines engaged. The machine did not dig delicately. It attacked the mountain through raw mechanical pressure. Hardened steel teeth fractured rock layers while steam-powered drag systems forced the bucket forward through soil, ore, and broken stone simultaneously. Entire sections of hillside collapsed inward as the bucket filled. Then the hoists reversed, lifting hundreds of tons upward in a slow arc toward waiting railcars or crushing stations below. Each cycle consumed extraordinary energy. The boilers required constant feeding from coal crews working in unbearable heat. Furnace temperatures often exceeded levels capable of blistering exposed skin within seconds. Workers shoveled fuel continuously while monitoring water levels and steam pressure because boiler failure inside the machine could trigger explosions powerful enough to tear through multiple compartments. Maintenance crews faced different dangers. Lubrication workers crawled through narrow access spaces beside moving gears coated in hot industrial grease. Riveters inspected structural joints weakened by vibration stress. Mechanics replaced damaged bearings while standing inches from rotating shafts large enough to crush a human body instantly if clothing became entangled. The machine demanded uninterrupted attention. A failed valve could destroy a steam chamber. A cracked support beam could collapse the boom. A seized gear could halt production across the entire mine. Industrial newspapers celebrated the giant's power, but few acknowledged how fragile such power truly was. The machine operated near the edge of its mechanical limits. Every hour it remained active. Engineers compensated through constant inspection, improvisation, and overbuilt reinforcement systems that increased the machine's already enormous weight. Weather intensified every weakness. Winter froze lubrication lines and stiffened cables until they fractured under tension. Summer heat expanded steel components unevenly, creating alignment failures deep inside the drive systems. Rain transformed excavation pits into unstable mud basins capable of trapping entire traction assemblies beneath shifting ground. Yet production quotas never slowed. Mining corporations calculated output in tons per hour. Delays cost money. Shutdowns threatened contracts. The machine therefore continued operating through storms, freezing temperatures, electrical failures, and structural warning signs that would have halted smaller operations immediately. Inside the control cabin, operators learned to recognize danger through vibration alone. A healthy drive train produced deep, rhythmic pulses through the floor plates. Misaligned gears generated irregular shaking patterns. Overloaded hoists transmitted sharp metallic impacts through the cabin walls. Veteran operators often detected mechanical failures seconds before gauges reflected abnormalities. Even then, reaction time remained limited. The giant possessed too much momentum, too much pressure, too much force already in motion. And once the excavation cycle began, stopping 12,000 tons of moving steel became a problem no engineer could solve quickly. The machine transformed mountains into ore with terrifying efficiency. But every hour it operated, the probability of catastrophe increased quietly inside the metal heart of the colossus itself. At first, the warning signs appeared small. Hairline fractures spread across excavation walls after blasting operations. Drainage channels clogged with loose sediment. Support roads collapsed beneath overloaded freight wagons carrying ore away from the pit. Engineers logged the incidents in maintenance reports, ordered reinforcements, and continued production. But the machine was digging deeper than the mountain had ever been forced to endure. Every excavation cycle removed another layer of structural balance that had held the terrain together for thousands of years. Entire sections of hillside now rested on weakened foundations hollowed by aggressive extraction. Vibrations from the giant's drive systems traveled through fractured rock formations like controlled earthquakes. During peak operations, nearby workers described feeling the ground pulse continuously beneath their feet. Then the landslides began. In the winter of one particularly severe mining season, a retaining wall above the eastern excavation shelf collapsed without warning after days of heavy snowmelt. More than 40,000 tons of mud, rock, and frozen debris thundered into the lower pit. Rail lines disappeared instantly beneath the avalanche. Ore cars overturned like toys. Several workers escaped only because the machine operator detected unusual movement along the quarry face seconds before impact and sounded the emergency whistle. Others never reached safety. Recovery crews spent 3 days excavating the buried section with smaller steam shovels, while unstable ground continued shifting around them. Bodies emerged slowly beneath crushed timber and frozen earth. Corporate reports classified the incident as a geological accident aggravated by weather conditions. The workers called it something else. They believed the mountain itself was beginning to collapse under industrial pressure. Mechanical systems suffered alongside the terrain. The giant's immense weight created enormous stress concentrations beneath its traction assemblies. As excavation pits widened, the underlying ground became softer and increasingly unstable. Sections of crawler track occasionally sank several feet into mud and fractured stone during operation. Extracting the machine from such conditions required auxiliary locomotives, winch systems, and entire crews working around the clock. Steam pressure failures posed even greater danger. The boilers powering the giant operated near maximum capacity during heavy excavation cycles. Any interruption in water circulation risked catastrophic overheating. In one incident, a pressure relief valve jammed partially shut during winter operations. Superheated steam ruptured through a weakened pipe seam with explosive force, filling a maintenance corridor instantly. 2 mechanics died before they could escape. Another suffered burns, severe enough that co-workers later claimed his boots had fused into the steel floor plates beneath him. Even routine operations carried constant risk. Steel cables weakened through repeated stress loading and exposure to freezing temperatures. When cable strands snapped, they released enough kinetic energy to slice through support beams, machinery housings, and human bodies alike. Veteran miners learned never to stand directly beside tension lines, though production demands often forced crews into dangerous positions anyway. The excavation pits themselves became increasingly unstable ecosystems of noise, dust, vibration, and hidden pressure. Blasting operations fractured underground water channels. Rainfall collected unpredictably in weakened soil layers. Dynamite crews occasionally triggered secondary collapses larger than the intended detonations. Some pits descended so deep that sunlight disappeared from their lower levels for much of the day, leaving workers surrounded by artificial floodlights and drifting steam clouds beneath walls of unstable rock. Engineers attempted solutions constantly. Retaining systems were reinforced with timber and steel anchors. Drainage pumps operated continuously to reduce flooding risk. Survey crews monitored shifting terrain with measuring instruments placed along quarry ridges. Yet every safety measure remained temporary because the machine's purpose fundamentally required destabilization. To feed industrial demand, the mountain had to come apart. The deeper the giant dug, the more unpredictable the earth became beneath it. What had once appeared solid and permanent slowly transformed into fractured terrain balanced under enormous stress. Some workers described hearing deep cracking sounds from within the quarry walls late at night after operations slowed. Others refused to work certain excavation levels entirely, convinced collapse was inevitable. Management dismissed such fears publicly. Privately, even senior engineers recognized the truth. The machine had become so large and extraction so aggressive that no one fully controlled the environment surrounding it anymore. Industrial power had reached geological scale, and geology was beginning to resist. Long before sunrise, the camp whistles began. Their sound carried across frozen rail yards, muddy boarding districts, and rows of company housing built from rough timber and cheap brick. Men emerged into darkness, wearing heavy coats stiff with coal dust and grease. Some had arrived only weeks earlier from mining regions in Croatia, Italy, Finland, Wales, or the Appalachian Hills. Others had spent years moving between extraction camps across the American frontier, following whichever corporation promised steady wages through winter. Most understood the same reality by the time they reached the quarry. The machine ruled everything. Shift schedules revolved around its operating cycles. Sleep patterns depended on boiler demands. Meal breaks ended when the emergency whistle sounded. Entire crews could be ordered back into freezing pits at midnight if the giant stalled beneath load pressure, or if a production quota fell behind schedule. The closer a worker stood to the machine, the harsher life became. Boiler crews endured the worst conditions underground the superstructure. Furnace compartments remained brutally hot, regardless of season. Coal dust mixed with steam until the air itself felt heavy enough to choke. Men shoveled fuel for 10 or 12 hours at a time beside fireboxes glowing white-orange through cracked steel doors. Sweat soaked their clothing even during sub-zero weather outside. Water consumption became a constant problem. Many workers suffered exhaustion long before shifts ended, but slowing the boilers threatened the entire excavation cycle. Supervisors pushed crews relentlessly because every interruption reduced ore output. Boiler workers often developed burns across their arms from steam leaks or accidental contact with heated pipe surfaces. Medical treatment inside the camps usually consisted of bandages, whiskey, and instructions to return once the bleeding stopped. Higher within the structure, maintenance crews navigated narrow steel walkways suspended above moving machinery. The giant never truly rested. Even during partial shutdowns, sections of the drive systems remained active for pressure regulation and positioning. Mechanics crawled beside rotating shafts while carrying tools slick with grease and vibration. Riveters hammered replacement plates into weakened joints while the entire structure trembled beneath them. A moment of lost footing could send a worker falling through open maintenance gaps into gear housings or cable assemblies below. Deaths were common enough that crews developed rituals around them. When accidents occurred, operations usually paused only long enough to remove bodies from visible work areas. Production pressure discouraged prolonged stoppages. Co-workers often completed shifts beside machinery still stained from incidents earlier that same day. New laborers arrived constantly to replace the dead, many desperate enough to accept conditions others abandoned. The noise never disappeared. Workers described hearing the machine even while trying to sleep. The repetitive concussion of pistons, the scream of cables under tension, the grinding pulse of gears turning through rock layers deep beneath the quarry floor. These sounds became permanent inside the mind after enough months near the excavation pit. Some men eventually lost portions of their hearing entirely. Others developed tremors in their hands from prolonged vibration exposure. Many simply disappeared. Mining camps built around large extraction projects often existed beyond meaningful public oversight. Corporations controlled housing, medical services, stores, wages, and transportation simultaneously. Injured workers unable to continue labor frequently found themselves evicted from company property within days. Families depended entirely on continued employment, because losing work also meant losing shelter and access to food supplies shipped into remote regions. Immigrant laborers suffered additional vulnerabilities. Language barriers isolated entire groups within segregated housing districts. Supervisors exploited communication difficulties to suppress complaints over pay discrepancies and unsafe assignments. Dangerous tasks frequently fell upon recent arrivals unfamiliar with the machine's risks. Fatalities among immigrant crews rarely reached major newspapers unless strikes or public protests followed. Yet despite the conditions, workers continued coming. Industrial America promised wages unavailable elsewhere. A skilled machine operator could earn more in a month than agricultural laborers earned across entire seasons. Families trapped in collapsing rural economies viewed mining employment as survival rather than opportunity. Some workers endured the camps long enough to purchase homes or establish businesses elsewhere. Most did not. Alcohol became the dominant escape throughout the quarry towns. Saloons filled each evening with exhausted crews attempting to silence the machines still echoing inside their skulls. Gambling halls operated beside brothels and boarding houses crowded with transient laborers. Violence erupted frequently after paydays when frustration, exhaustion, and debt collided inside confined industrial settlements. The psychological pressure spread upward through management as well. Supervisors faced relentless production demands from corporate offices, measuring success almost entirely through extraction totals. Engineers responsible for structural safety balanced impossible choices between shutdowns and output quotas. Machine operators carried enormous stress because a single error could bury entire crews beneath collapsing excavation walls. Many workers developed superstitions around the giant itself. Some believed the machine possessed moods reflected through changes in vibration or sound. Others refused to enter certain maintenance corridors where previous accidents had occurred. Stories circulated of operators hearing voices through steam vents late at night or feeling the structure shake before major collapses occurred. Rational or not, such beliefs reflected a deeper truth. The machine had become more than equipment. It dominated the landscape physically, economically, and psychologically. Entire communities existed only because it consumed mountains each day. Men organized their lives around its demands. Families survived or starved according to its production schedules. And beneath all the steel, smoke, and industrial ambition remained a terrifying understanding shared quietly among the crews who operated it. The giant could kill them at any moment, and eventually, for many of them, it would. It began with a vibration that felt different from all others. Not the steady pulse of gears, not the heavy rhythm of hoists lifting fractured stone. This was sharper, irregular, as if something deep inside the machine had begun to lose alignment under forces it was never designed to endure for so long. Operators in the control cabin noticed it first through the floor plates, small, uneven jolts that interrupted the usual mechanical cadence. Within hours, the anomaly became visible. A major drive shaft inside the lower gear assembly had begun to fracture under accumulated stress. For weeks, engineers had recorded micro cracks in inspection reports, but production demands had delayed a full shutdown. The shaft, responsible for transferring torque from the steam engines to the bucket hoist system, was operating beyond safe tolerance levels. Every excavation cycle pushed it closer to catastrophic failure. Then it gave way. The sound was not a single explosion, but a violent chain reaction. Metal sheared against metal with such force that it echoed across the entire quarry like a thunderclap trapped inside steel. The rotation system jerked violently, sending shock waves through the boom assembly. The bucket, suspended mid-cycle with nearly 90 tons of rock, swung uncontrollably before slamming into the excavation wall. The impact triggered a secondary collapse. A section of the quarry face, already weakened by weeks of vibration and rainfall, gave out entirely. Thousands of tons of rock and soil poured into the pit in a cascading wall of debris. Rail tracks were buried instantly. Ore carts disappeared beneath collapsing earth. Emergency whistles sounded across the site, but their warnings were drowned beneath the roar of falling stone. Workers ran, but the terrain itself was breaking apart beneath them. 3 men working on a lower maintenance platform were caught before they could reach the exit ladders. Their section of the structure buckled as supporting beams snapped under shifting load stress. The platform dropped into the debris field and vanished. Rescue efforts began immediately, but conditions were unstable. Every attempt to clear the collapse zone risked triggering further landslides. Steam-powered excavators worked alongside crews using manual tools, digging through unstable layers of rock that continued shifting underfoot. The giant itself stood partially immobilized, its damaged drive system locked in a half-rotated position like a wounded animal frozen mid-motion. Production stopped for the first time in months, and silence, when it came, revealed how unnatural the machine's constant presence had been. Within days, labor tension erupted across the entire mining operation. Workers refused to re-enter unstable excavation zones without structural guarantees. Boiler crews demanded inspection of all pressure systems before restarting furnaces. Maintenance workers pointed to ignored warning reports documenting mechanical fatigue in critical components. The collapse had not been an accident, they argued, but the inevitable result of continuous operation beyond safe engineering limits. Management responded with urgency rather than reflection. Orders were issued to restore partial operation within days. Financial contracts depended on uninterrupted ore delivery. Rail companies threatened penalties. Furnace operators downstream had already begun rationing material. The machine, even damaged, was still considered too valuable to remain idle. This decision ignited the strike. Crews walked out of active sections of the quarry, abandoning tools and shifting camps into protest lines near the rail depots. The demand was not only wages, It was survival conditions, reduced hours, reinforced safety inspections, and structural repairs to the machine before full operation resumed. Company officials refused to negotiate under shutdown conditions. Tensions escalated rapidly. Security personnel were deployed around key infrastructure points. Temporary fencing went up along rail loading zones. Supplies entering the camps were restricted. The strike turned into a standoff between the people who maintained the machine and the system that depended on it. Inside the damaged giant, engineers faced an impossible contradiction. Repairing the drive shaft required full disassembly of sections that weighed hundreds of tons. Reinforcing the structure would take weeks, yet restarting production without repairs risked another collapse, potentially larger, deeper, and far more destructive than the first. The machine had reached a point where it could no longer be operated safely, but shutting it down threatened the economic system built around it. And so it remained suspended between two forms of failure: mechanical collapse or industrial collapse. Neither option offered stability, only consequence. The ore did not stay in the mountains. Even as the giant stood damaged and partially silent in the quarry, its past production continued moving through the arteries of American industry. Rail cars loaded in previous months kept rolling eastward and southward, carrying the remains of entire landscapes toward furnaces that never cooled. At the steel mills, the mountain became something else entirely. In Pittsburgh, Chicago, Cleveland, and Gary, rail yards emptied their cargo into towering blast furnaces where temperatures exceeded 1,500 degrees Celsius. Iron ore, once locked beneath frozen rock layers, dissolved into molten form and re-emerged as structural beams, rivets, and plates. What had taken millions of years to form in geological silence was transformed in hours into material capable of reshaping cities. Bridges rose across rivers that had once divided territories. The Mississippi was spanned by steel frameworks, so massive they appeared to float above the waterline like industrial skeletons. Rail networks expanded further west, cutting through plains and deserts with mathematical precision. Freight systems tied agricultural production zones to manufacturing centers in a continuous cycle of extraction and construction. Every structure carried invisible fragments of the machine. Skyscrapers in New York were built using beams forged from ore, excavated by giants like the 12,000-ton excavator. Factory floors in Detroit supported assembly lines producing automobiles that would define a new century of mobility. Naval shipyards constructed armored vessels whose hulls were thick enough to withstand artillery fire, all relying on steel, whose origins traced back to the same industrial pits. War accelerated everything further. As global tensions increased in the early 20th century, steel demand surged beyond peacetime levels. Artillery shells, naval cannons, armored plating, and rail-mounted logistics systems required enormous quantities of refined metal. Mining output was no longer just economic infrastructure. It became strategic necessity. Governments depended on uninterrupted industrial extraction to sustain military readiness. The machine's role became indirect, but absolute. Even when it was not operating at full capacity, its earlier production cycles continued feeding supply chains that stretched across continents. Entire cities owed their existence to the ore it had already removed from the earth. Rail companies calculated schedules based on its historical output. Steel mills structured production cycles around its legacy deposits. Yet the empire built from this extraction carried a hidden cost that was rarely acknowledged in official records. Mining towns at the source regions experienced rapid cycles of expansion and abandonment. When ore quality declined or excavation zones became too unstable, companies relocated operations, leaving behind empty housing blocks, rusting rail lines, and exhausted terrain scarred beyond recovery. Entire communities dissolved once the industrial attention shifted elsewhere. Environmental transformation was permanent. Hills were flattened into pits. Forests disappeared into smelters. Water systems carried decades of sediment and chemical runoff downstream. The landscape surrounding the machine's excavation zone no longer resembled natural geography. It resembled industrial aftermath, a terrain shaped entirely by extraction logic. And yet, within financial reports and engineering summaries, the machine remained classified as a success. It had met production targets. It had exceeded output expectations during peak operation periods. It had reduced labor dependency per ton of ore extracted. These metrics defined its legacy in official terms. But among workers, engineers, and those who lived closest to its operation, the memory of the machine carried a different weight. They did not measure it in output. They measured it in instability, in collapsed walls, in broken bodies, in nights when the ground itself seemed to move beneath their feet. The empire built from torn mountains stood as evidence of what industrial scale could achieve when pushed beyond natural limits. But it also raised a question that no report could fully answer. What remains of a world once the mountains that held it together are gone? The machine did not end in a single moment. It faded through a series of operational compromises that stretched across years, each one smaller than the last, but collectively irreversible. After the major collapse and strike, the giant returned to limited service, but it never again operated at full capacity. Engineers reinforced fractured drive components, replaced weakened cables, and stabilized sections of the boom assembly with temporary steel bracing that was never truly temporary. Every repair introduced new imbalance, new vibration patterns, new stress points, new uncertainty. The mining industry around it was changing faster than the machine could adapt. Electrification began replacing steam systems in newer excavation sites. Smaller, more efficient machines were introduced that required fewer workers and less maintenance downtime. Rail logistics improved to the point where centralized superstructures were no longer economically necessary for many operations. The 12,000-ton giant became too large for an era that was learning to be precise, not just powerful, efficient. Corporate accountants began evaluating its cost per ton of ore against newer systems. The numbers no longer favored it. Its maintenance demands consumed entire engineering teams. Its downtime increased with every operating cycle. Insurance costs rose due to structural instability risks. Even its once impressive output became inconsistent. Then came abandonment by degrees. First, certain excavation zones were permanently closed due to instability. Then, night shifts were reduced. Then, entire boiler sections were decommissioned. One by one, the systems that gave the machine its full capability were shut down. Not in protest or disaster, but in quiet, administrative decisions made far from the quarry floor. Eventually, only partial operations remained. A fraction of the original workforce continued maintaining what was left, mostly to extract remaining accessible ore deposits already exposed during earlier decades of aggressive excavation. The machine still moved, but it no longer dominated the landscape. It lingered like an aging structure, too large and expensive to dismantle immediately, and dismantling it was the final impossibility. A machine of 12,000 tons could not simply be removed. Its own scale made it resistant to removal. Cutting it apart required resources comparable to its original construction. Transporting sections away was economically unviable. So instead, it was left in place, decommissioned, partially stripped, and slowly consumed by rust, weather, and geological instability. The quarry itself continued changing around it. Rain filled lower excavation zones, creating artificial lakes that reflected the rusting superstructure like distorted memory. Vegetation slowly returned to the outer edges of the mining site, creeping inward across abandoned rail lines. Birds nested in skeletal beams that once carried thousands of tons of steel across the pit. Occasionally, former workers returned. Some came to see what remained of their labor. Others simply passed nearby and stopped without planning to. Standing at the edge of the transformed landscape, they saw not a machine anymore, but a ruin of industrial ambition, half structure, half terrain, impossible to separate from the ground it had reshaped. Younger generations heard stories, but rarely understood the scale. To them, it was history. To those who had worked inside it, it was something closer to memory that refused to settle. The giant's decline did not erase its impact. It redistributed it into landscapes, into infrastructure, into cities built from its extracted past, and into the lives of those who had once stood beneath its shadow, listening to the constant rhythm of steel and steam as it tore mountains apart in the name of progress. The machine did not disappear. It simply stopped moving. And in that stillness, it revealed its final truth. That industrial greatness is not measured by what is built alone, but also by what is permanently altered in the process of building it. Long after the last boiler went cold, the landscape still carried the machine's memory, not in sound, not in movement, but in from. The quarry remained carved into the earth, like a wound that never fully closed. Its edges softened by time, its depths filled in places with dark water and sediment, its walls layered with the scars of repeated collapse. What once echoed with steel impact and steam pressure now held only wind, distant bird calls, and the slow settling of stone. Yet the absence was deceptive, because nothing about the machine truly ended where it stood. The mountains it removed had already been converted into bridges that still carried traffic across rivers, into rail lines that continued binding states together, into skyscrapers whose silhouettes defined city skylines long after the original industrial boom had faded. Its physical body was gone from motion, but its material consequences remained embedded in every direction. Steel does not forget its origin, nor does infrastructure erase its source. In nearby towns that once depended entirely on its operation, the effects were more personal. Some communities stabilized after the mining cycles ended, shifting toward rail maintenance, manufacturing, or service industries that grew around the old extraction routes. Others declined slowly, losing population as jobs disappeared and industrial attention moved elsewhere. Abandoned company housing deteriorated into hollow structures of timber and rusted nails. Rail spurs that once carried constant ore shipments became overgrown paths cutting through returning vegetation. Entire districts were absorbed back into geography, as if the land was reclaiming spaces temporarily loaned to industry. For those who had worked inside the giant, memory became the most persistent structure. They recalled the vibration before they recalled the details, the constant pressure underfoot, the sound of gears turning somewhere beyond sight, the feeling that the machine was never truly still, even when it was idle. Some spoke of it as if it were a place rather than equipment, a location you entered and survived, rather than a tool you simply operated. That language persisted because scale had changed perception. Nothing built on that magnitude behaved like ordinary machinery. It shaped time, routine, and even fear. Engineers later studied its design as a historical artifact. They examined its stress tolerances, its mechanical failures, its modular systems, and its catastrophic thresholds. They learned what it could do and what it could not sustain. In engineering archives, it became a reference point for maximum-scale steam excavation. a boundary case in industrial design where ambition exceeded long-term structural viability. Economists studied it differently. They saw efficiency curves, output peaks, decline phases, the transition from profitability to maintenance burden. In their language, it was a life cycle model of industrial overreach, an example of how scale can temporarily solve production demands while eventually creating unsustainable maintenance debt. But none of these interpretations fully contained what the machine represented, because its most lasting impact was not technical. It was physical. It changed the geography of an entire region. It altered how deeply humans could cut into the earth before encountering consequences that could no longer be controlled through engineering alone. And it changed perception itself. Before machines like it, mountains were considered permanent. Afterward, they were considered resources. That shift, quiet, gradual, and irreversible, defined its true legacy more than any production record or engineering achievement ever could. Today, what remains is a layered silence. Water where stone once stood, forests where excavation pits once roared, cities far away built from material that passed through its gears without ever knowing its name. The 12,000-ton steel giant no longer exists as motion, but it continues to exist as structure. Distributed across the modern world, it helped construct, hidden inside bridges, buildings, railways, and industrial systems that still shape daily life. It did not simply move mountains. It redefined what mountains were allowed to mean. And in that redefinition, its presence never truly ended. It only changed form,